Homework help video for the polynomials quiz review. Let's jump in with problem number 1 here. Identify the vertex and axis of symmetry of each, then sketch the graph. So these equations are both of the form y equals a times x minus h squared plus k. And the vertex, when it's in this form, is always going to be h comma k. So I just have to look for my h and my k value. Now you might be tempted to say that h is 2 here, but h is actually negative 2. Because of this built-in minus, we need another negative to counteract it to get that plus. K is a negative 3 though, so that one we don't flip. And we can go ahead and put our vertex where it's supposed to be, negative 2, comma negative 3. Make a point. I would say we have identified the vertex at this point. You might want to say vertex right there. Now for the axis of symmetry, that's a vertical dotted line that goes right through that vertex. So I'm going to add in that dotted line and I can label it. It's a vertical line, so it gets an x equals equation. X equals negative 2 is my axis of symmetry. All right, now to get the sides of this parabola. Our parent function, y equals x squared, every time we move 1, 2, or 3 away from the vertex, we go up 1, 4, and 9. But that's not what this one's going to do, because we have doubled it. We've put a 2 in front here. You know, the 2 is way in front. It still counts as being in front. That means I'm going to double each of these to become 2, 8, and 18. So for my vertex, I move 1 unit out. I go 2 units up. Make it symmetrical over that axis of symmetry. I go back to the vertex. I go 2 units out, this time 8 units up. 1, 2, 3, 4, 5, 6, 7, 8. Make it symmetrical, and then I would go 3 units out, 18 up, but I can't fit that on, so I'll just do my best to draw a curved line that hits all of these points. All right, here's our parabola for number 1. Now I won't do number 2, but I will tell you that the 1, 4, 9 is going to become negative 1, negative 4, negative 9, because our a value right here is equal to negative 1. All right, convert to standard form. So standard form, let's just write that out, is y equals ax squared plus bx plus c. Notice there's no parentheses here, so we got to get rid of the parentheses. To get rid of the parentheses in problem number 3, we need to expand this exponent. So this becomes negative 18 times x plus 4 times x plus 4. Keep the minus 3 at the end. Binomial times a binomial, I need to FOIL that. So first, outside, inside, last. Now keep the negative 18 out in front and then put the rest of this in a set of parentheses. X squared plus 4x plus 4x plus 16, close parentheses, minus 3. Combine like terms in here, that 4x and that 4x can become an 8x, so negative 18 times x squared plus 8x plus 16 minus 3. Now distribute in that negative 18 to each of these terms. This would be a good time to grab my calculator. And I get, I'm still not done simplifying, but I get negative 18x squared, then 18 times 8 is 144, so negative 144x, 18 times 16 is 288, so minus 288. Minus 3 is still hanging around at the end. Combine like terms, and it's a good time to bring that y back in. We get y equals negative 18x squared minus 144x minus 291. All right, in that standard form, I can clearly see what the a, b, and c values are. All right, end behavior and y-intercept, we want both. So for end behavior, I only care about 2 things. I care about the sign of my leading coefficient. This one is positive. and whether or not my degree or biggest exponent is even or odd. This one is odd. So if it's positive, it's going to end up, and if it's odd, the end behaviors are not going to match. So we get down, up, end behavior. So that answers the first part. And then for the y-intercept, it's just that minus 15 at the end. I'll just draw an arrow to it and say y-intercept. I think that's fine. All right, we'll do this one. This one is positive and even. So it's positive, so it's going to end up. It's even, so the end behaviors are going to match, so we get up, up. And that's our y-intercept right there. Okay, let's see this one. Negative and odd, so it ends down. And it's odd, so they don't match, so it's up, down. There's your y and t. And then we got positive and even, so up, up. I think we got an example of each there, did we? We got, no, I don't think we had a down, down. No, we didn't have a down, down. We had two up, ups though. If we wanted a down, down, we would need negative and even. All right. Find all roots. So don't be tricked into foiling this. That's not going to get you any closer to solving this. Remember, roots, another word for that is just solutions. We want to find all solutions. Well, there's an easy way to make this equation balance, and that's make one of these two factors equal to 0. Because if I can make one equal to 0, it doesn't matter what the other one is. 0 times anything equals 0. I found a true statement. So I set each of these equal to 0. All right, finish solving. Minus 5 or plus 5 plus 5. We get x equals 5. Minus 3 minus 3. We get x equals negative 3. You will notice it is always this number flipped as long as there's not a coefficient. This one here, with that x in front, that just means that x equals 0 is one of our solutions. And then the other two are x equals negative 3 and x equals positive 1. Notice how I flipped those. Solve each equation by taking square roots. The reason that we are allowed to solve by taking square roots here is the fact that we don't have a b value. If there was a b value, we would need to use something like the quadratic formula, but that means there's not a second variable somewhere in this equation that's going to get in our way. So I'm going to subtract 1 from both sides. I get 49a squared equals 36. Divide both sides by 49. I get a squared equals, leave this as a fraction, 36 over 49. To get rid of that squared, take the square root. So now I've got a equals the square root of 36 over 49. But there's a way to simplify this. 36 and 49 are both perfect squares, so I can rewrite this as the square root of 36 over the square root of 49, which equals 6 over 7. Put a plus or minus in front because that's what we always get with square roots, is a positive and a negative. All right, let's practice quadratic formula. We'll do it with 13 here. What I'm going to do, I'm going to subtract 3n from both sides because I need this to be set equal to 0. And then I'm going to write it in standard form. 2n squared minus 3n minus 65 equals 0. Now I can quickly identify what my a, b, and c values are. A is equal to 2, b is equal to negative 3, and c is equal to negative 65. And plug those right into my quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's plug it in. And we're going to try to do as much as we can in our head. So we're not going to write stuff like negative 3 when I plug a negative 3 in here for b. We're just going to flip that to be a positive 3. And then b squared, well, negative 3 squared is negative 3 times negative 3 becomes a positive 9. Common mistake is to end up with a negative in front there, but b squared will always be positive. Minus 4 times 2 times negative 65 all over 2 times 2, which is 4. All right, now we just simplify. 3 plus or minus the square root. You can plug this whole discriminant into your calculator in one line, but I wouldn't do any more than that. I would just stop there. So 9 minus 4 times 2 times negative 65. I get 529. I'm going to try taking the square root of that just to see if it's an integer. I get exactly 23. So I can keep going on this. 3 plus or minus 23 all over 4. And then at this point, split up that plus or minus. Split it into 3 plus 23 over 4 and 3 minus 23 all over 4. And simplify both of these. We get 26 over 4 equals 6.5. And negative 20 over 4 equals negative 5. There's your two answers. All right, 15. I'm going to do this one, but I'm going to go a little bit quicker. But it is a little bit different. So I move that 8p over. So that this is in standard form. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Simplify negative 8 plus or minus the square root. Do this in my calculator. 64 minus 4 times 5 times 7. It's fine to put that just in one line. I get negative 76 all over 10. What I want to do here, I've got a negative. I'm just going to bring that negative out as the letter I. Negative 8 plus or minus the square root of 76i all over 10. And that's fine. That is simplified enough. I know technically square root of 76 could be simplified a little bit further, but it's not a perfect square, so I'm just going to leave it like that. All right, I'll end part 1 here. Resume in the next video.